So today we're going to be able to graph a line using a point and the slope. At this point, all of the graphing that we have done has required us to use an equation and use plug and chug. Today is going to be a little bit different. We're not going to be given an equation. We're just going to be given some information about the line. We're going to be given a point that is on the line and the slope of the line. So in order to do that, we've got to be thinking some things about what we know about that information, because we're not going to be able to plug and chug today. So the first thing we really need to think about here is, how have we shown slope on a graph previously? When we've been doing problems where we have a coordinate grid and we have a line on it and we wanted to find the slope, how did we physically or visually show the slope on the coordinate grid? Rebecca? Yeah, with our slope triangles. And so what we often do is we use with rise over run, slope triangles. Great thing about slope triangles, and one of the reasons why I teach slope triangles, is because slope triangles are multi-useful. They are not only useful for finding the slope, they can also be useful for using the slope. So today we're going to be talking about how we're going to use that slope. Now, if I tell you I have a line that has a slope of 1/2 and a point on it is 2, 3, what do you think the first thing I should do is if I want to graph that line? Jose? Plot the coordinate. Okay, so we're given 1 point. That's on the line. Absolutely. So from here we know that we need at least 2 points in order to graph a line. So we need to find a way to use the slope to find another point on the line. This is where using slope triangles can help us out. How can I use a slope triangle to find the next point or another point on this line? Malcolm.
Use the slope to go up 1 and 2.
So Malcolm is thinking about his slope as being a rise over a run. Absolutely label that every time. That way you're thinking about it. And so from here he's saying, I need a rise from this point, 1, and I need to run from this point, 2. And that should be another point on the line. I always want to go ahead and do a third point just to get everything all lined up so we can draw the straightest line possible. It's easier to draw a straight line through 3 points than it is 2. It's just more accurate. So how do you think I'm going to find a third point? Up 1, following that rise. Run, follow that run, gives us a third point. Then all we need to do is break out our trusty straight edge. I'm rocking a ruler today.
Rocking a ruler.
You may not borrow it because it's my straight edge for today. You should get your own.
Who told you? You can say that again.
If I don't see you using a straight edge right now, you're probably not doing what you're supposed to.
That's exactly why you gonna hand that on.
So, easy peasy. All we need is a point on the line and the slope. Then we can use slope triangles from that starting point to find other points. Easy as that. The reason why this skill is super important, it's a really, really easy concept for today. But this is going to help us graph equations later on. We're going to be able to look at an equation, draw information from that equation about the slope and a point on the graph. And instead of having to plug and chug, if we can do this, we can graph some of those equations a lot more quickly. Okay? So let's go ahead and look over at a couple more examples. I think most of you could probably actually take the one example and just be done with the rest of the day. There are a couple more things that I do want to make sure we encounter before we move off independently. All right, so looking at this next one, it tells us there's a point on a line. It's 0, 3. The slope is negative 3 over 4. What do you think the first thing we need to do is here? Javier.
Check if it's negative or positive.
So he's checking if it's negative or positive. That's probably one of the last things we want to do, so we can compare our line to the slope, but that's definitely one good check. But if I want to start graphing this point, or graphing this line, me giving away the answer, Javier, I should probably what? Yeah, so take my point and graph it. Over 0, up 3. But that's only 1 point. It takes 2 points to graph a line. How am I going to find that next point? How am I going to find that next point, Raisa? Wait, down 3? Why down 3?
Go to the left.
Hands. Why down 3, Maureen? Because the rise is negative. So we're going to go down 1, 2, 3 and run positive 1, 2, 3, 4. How am I going to get that third point? How am I going to get that third point so I can get that nice straight line?
Make another one.
Make another one. How am I going to make another one?
Go down 3.
Yeah, follow the rise and run again. So our rise says down negative 3 and run positive 4. There we got that third point. We can draw a nice straight line. And we're good to go on this one. We do want to really quickly, though, think about what Javier said. He said, well, check if it's negative or positive. Did we draw a negatively sloped line?
No.
Did we draw a negatively sloped line?
Yes.
Were we given a negative slope?
Yes.
So that's all good.
Yes, all good.
One more thing that's a little bit different. What's a little bit weird about this one? Thank you for raising your hand, Madeline. What is weird about this one? Sorry, Madeline, I couldn't hear you. It's not a fraction, so we don't have a rise and a run here. There's no rise over run. Fernando. Put it over 1. Make it a fraction. If we're not given a fraction, make it a fraction. Put it over 1. Whole numbers over 1. Other than that, same thing. Now I've got a rise and a run to label. I've got a point to graph, negative 2, 3. After labeling my rise and run, I've got something to follow to get my next point. It says 2 is the rise, so that's up 2. 1 is the run, that's over 1. One more time to get that third point, up 2, over 1. I got my 3 points for a nice straight line. Break out that straight edge.
No, it's not. I put it in there. Put it in there.
And you got a line. Make sure you're looking at the slope there. So, my question to you, Kip yes or Kip no? Are you ready for this? You're not ready. I can tell you're not ready. Kip yes or Kip no? Is this a whole lot easier than plug and chug?
Yes.
This is a whole lot easier than plug and chug. That's why we learn this skill, because there are some equations that we can use simply this skill instead of having to do plug and chug. let's look at one more example to make sure that we're all set and ready to go. I've given a slope of -3. Again, I've got that issue. I don't have a rise and a run. Gene, what do I need to do if I don't have a rise and a run? I've just got a whole number. Put it over 1. Now I can label my rise and my run. We're going to find that starting point. This is a very commonly misgraphed starting point. 2, 0, not 0, 2. So that means over 2 and up 0. Now we just follow. Rise over run. Rise. 1, 2, 3. Run. 1. Rise. 1, 2, 3. Run. 1. Good. I see some hands up. What's wrong with what I did?
The 3 is negative.
The 3 is indeed negative. So, I need to go back to my starting point. A negative rise means I need to go down. So rise, 1, 2, 3, down, and run 1, positive or backwards? Forward or backward? It's positive, so we're going forwards. Get that straight edge back. And let's make a line.
Oh, yeah.
It's Kirby?
Yeah, Kirby.
Like the Nintendo character?
Yeah.
No, like that car.
You know, he gets fat and then he gets.
Or Kirby, alright, that's a good one.
Go, Kirby, go.
Okay, let's come up back to our key points.
I think I missed
2 key points here today. Who can give me the first key point about graphing a line using point and slope? Marlon. Key point. Graph the point first. Then what?
Then use the slope. To do the run thing.
To follow rise over run to the next point. Perfect. Couldn't have said it any better myself.
Hey, get rid of football sometime. You go up 3 feet, and you go up. And just keep on doing it. You got rid of them.
Second key point. We'll come back to the first one in a second. Let's look at the second key point. Yes, sir.
What is that part again? You got a number right there, and it's not.
That's a whole number. So
You got stop sign right there. All right, you got a whole number. You got a out of 1 number.
perfect. When you have a whole number slope, put a 1 underneath to get rise over run. Couldn't have said that any better myself.
I know, did I say it?
I mean, he said it first. I was just copying what Kendrick said. All right. Are there any questions as we move forward?
Can I see the first one?
Yes, let's move it so we can see both those key points and get them both down. Yes, Adriana. Okay, so Adriana is getting on to a point that I want to make about our first together time problem. So let's go ahead and flip over to our first together time problem. I'm going to give you 30 seconds to get started on that independently, and then I'm going to interrupt you because I think some of you are going to have a question. Okay? What's the issue that we've run into here? Graciela? There's no more space to put a point. We can't rise 2 and run forward 5 again. However, there is one way to solve this problem. Kenneth? Go backwards the other direction. So instead of rising 2, we would be going -2. And instead of running forward 5, we would be going backward 5. If I look at how I write that as a slope, I get -2 over -5. Is that the same thing as +2 over 5?
Yes.
Absolutely, because a negative divided by a negative is a positive. So anytime
You see it, right?
anytime that we have that problem where we run out of space, we can always change our positives to negatives, negatives to positives, so we can go backwards, just in reverse order.